The broadcast is now starting. All attendees are in listen-only mode.
Hey everybody, welcome back to Young Engineers of Today. Apologies for the tardiness. I ran into some technical issues, but I'm here now, and we're here to continue working with the bridge designer. Um, just as I understand it, you guys probably got as far as downloading it and maybe taking a little bit of a look at it. We'll start from that point and move forward from there. So there will be, pretty much all today will be devoted to working through the Bridge Designer software. And we'll make as much progress as we can. We'll probably take it at a pretty leisurely pace, and then we'll leave it open for question and answer time and everything like that. Apologize, I'm running with a bit of a headache today too, so probably not going to be my usual sprightly self. Spastic, maybe another word for it. Anyway, so yes, Bridge Designer. I believe Mr. Dubik made you all aware of the fact that there is a Bridge Designer contest that he's going to run. Um, just as a quick recap, uh, you want to build the least expensive bridge that is able to hold as much weight as possible. We're going to need to use the 2015 version of the engineering design contest software, which should not be an issue. I believe you guys probably got that all squared away on Monday. For the middle school, you'll get a $20 gift certificate to Adafruit, and you'll post your scores in Edmodo, so you can place everything there whenever you're um, satisfied with a bridge, and you can post as many designs as you'd like. So if you submit something and then you go, wait, I've got a better one, then you're more than welcome to do that. Okie dokie. Yeah, if you weren't here Monday, this is going to be the link for the Bridge Designer software. And you're just going to click on download over here. Actually, let me just go ahead and oops. That's actually the download flat out for 2015 for Windows. Unfortunately, if you're running on a Macintosh computer, it'll need to be 2016. He said 2016? Oh man. Okay. Yeah, we'll go ahead and get 2016 downloaded then. Alrighty. So if you have Windows, you'll be downloading 2016 from here. And if you have Mac, you'll be downloading, I'll label it, 2016 from there. All right, so I'm going to go ahead and get 2016 downloaded then. Okay, so it's Windows 2015 and Mac 2016. Okay. All right, well, that's fine then. If you're on Windows, go ahead and use the 2015 download. And if you're on Mac, go ahead and download the 2016. We'll give everybody a couple of minutes for that, and we'll resume at 7:15. What about documents in Google Classroom? I'm not sure. Does anybody have a link to that stuff? Because I wasn't aware that that existed. Cool. Would you mind linking it so I can check it out? Thank you. I appreciate it. All right, let's see here. Looks like, yeah, let's try that again. Oh, the link doesn't seem to be working. I appreciate it. I don't. We'll go over how to get started with all this stuff in just a moment, Cademan. All right, so let's see here. Yeah, it looks like the link isn't working for me. Oh well. No, you should not have to pay for this. It should be 100% free. At least for the purposes that we're using it. I don't remember, to be honest with you. Oh, lowest price is best. That's for the bridge, because there are costs associated with the materials for the bridge. Are you referring to? Yeah, 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 yeah. Okay, so West Point Bridge Designer. Um, Basically, it's a piece of software that's used in a yearly competition, in which people design the most cost-efficient bridge that's still strong as they possibly can. So to that end, we can take a look at what we got here. It's a fairly straightforward intro. Just either create a new bridge design or load a sample bridge design, or we can load an existing bridge design file. Loading an existing bridge design file is going to be stuff that we've worked on in the past. Sample bridges are going to be, sample bridges. And new design is going to be basically, it's going to have some minimal parts to it, but otherwise it's going to be more or less a blank bridge. And that's what we're going to work with, is we're going to start with a blank bridge. So if I go back here, so as you can see, the design requirement: as a civil engineer working for the State Department of Transportation, you are responsible for designing a truss bridge to carry a 2-lane highway across this river valley. Your objectives are to ensure that the bridge can carry its own weight, which is basically the weight of the materials that it's made out of, including the reinforced concrete deck, plus the weight of a standard truck loading, to keep the cost of the project as low as possible. And if you want to get, complete design specifications, you can click the help button, and it sort of gives you a whole bunch of stuff. You got overhead power lines, so you can't make it too tall. You got water level to worry about. Just a whole bunch of different things. All right, but this is pretty much just an explanation. As it says, read the design requirements, so this is an explanation of what you're going for. So we're just going to click next. So next it's going to ask if you're participating in a local bridge design contest. We are not. However, if you were, you would be getting a code. You could put it in there, and then you would be able to enter your design into that contest. And also, presumably, if there were any wrinkles in the design, they would automatically be included in the landscape design for the bridge. But again, we're not, so just go ahead and click next. Then we're going to get the deck elevation and the support configuration, which is the basic part of the bridge. So here, we can change the span, which is basically the distance. See, if we mess with this, it changes the distance that the bridge has to traverse. However, if we check down here in the it has what you? Oh, do you not have like enough space on the monitor to click the next, or is it just, wow, what kind of a resolution are you running at? Okay. I believe how much of the screen can you see? Because you can tab over to the next button if you need to. It's not exactly going to solve the issue of the rest of the UI, but at the very least, that would be, you'd be able to get past that. Okay. And you can't increase the resolution at all? Define wigs out. it's off the screen. Do you have multiple monitors or? Like you have no display at all if you change the resolution? Gotcha. Okay. I'm tracking now. Alrighty. Well, never mind then. If you hit the tab key, so once, if you hit the tab key, you can see that you get a dotted line around the stuff that you know, you've got selected next. Once you hit 2 cable anchorages, that'll be the last thing you can see before you're off the screen. You can just press it 1, 2, 3, 4, 5 more times. And then you'll be at the next button. Gotcha. No problem. In the meantime, yeah, so these are things that you can change when you're working on, like a bridge design for the competition. You can certainly change the deck elevation, which also changes the span that the bridge has to cross. Basically, what's going on here is the idea is that they're excavating. You're basically you're creating a plan for a bridge that needs to be set up first with excavation. So they dig out the hills on either side, the banks, not the hills, the banks of the river, and lower the elevation so that you will have to cross not quite as far. Now, keep in mind, you can probably see on my screen, the site cost changes pretty dramatically with that. It becomes more expensive the lower the deck elevation is. So on the one hand, you've got less of a span. On the other hand, you have to pay for a whole lot of excavation. In this case, it's $102,000 in excavation if you go all the way down to the bottom. So I'm going to keep it at the top, even if, that's not necessarily the most, even if that is the longest span, we won't have to pay for any excavation whatsoever. So our costs drop dramatically. It's about a half of what it was before. Yeah, roughly one half. And you've got different kinds of abutments, standard and arch. And what these do is these set the stage for basically the under the bridge support. So you can change that as well by making the arch taller. You can provide more support, but you're also going to make the bridge more expensive. The most significant difference in cost is going to come from having standard versus arch abutments as opposed to any change in how big those arch abutments are. Then you've got no pier and one pier. So you can basically have a spot in the middle that provides more support for the bridge. This is also decently expensive though. And finally, you've got cable anchorages, which will allow you can see it's just some small white circles that appear on either side of the bridge. And these allow you to anchor a cable to the ground so that you can create a suspension style bridge. Anyway, we're going to keep this as basic as possible. And I'm just going to click next. And then we've got deck material. Yeah, so this is all explaining that kind of stuff. We've got deck material and a truss template. We're going to keep the deck material at medium strength concrete. High strength concrete is roughly the same strength, but it will be more expensive concrete. On the other hand, it will also be thinner, so it'll be a much lighter truss to deal with, or deck to deal with, excuse me. So we're just going to say it's medium strength concrete right now. Though again, later on, if you feel like the cost can be affected positively, excuse me, I'm sorry for yawning. You can make it high strength concrete. And you've got loading, standard 225 kilonewton truck, 2 lanes, or 480 kilonewton permit loading, which is centered. We're just going to go with the 2 lanes. So the 225 kilonewton truck. Then you've got different types of trusses. And these are templates for your bridge. So you've got through truss, Howe, Pratt, and Warren, and deck truss, Howe, Pratt, and Warren. And basically the second part of it is the style of if you've changed anything in any of the previous ones that might affect what kind of style you have to work with. Yeah. So like if I do arch abutments, then I've got continuous arch and 3 hinge arch. Oh, okay, gotcha. Alrighty, well that's good. Oh, 2 cable anchorages. I getcha. Okay, so yes. These are going to be the different ones available to you. The second part just has to do with the style of the truss, or excuse me, the triangles that make up the truss. Howe is going to have the triangles pointing inwards. Pratt is going to have the triangles pointing outwards. Warren is going to have some equilateral triangles as opposed to these isosceles triangles, I guess, that they've got going on here. And then through truss means that the truss starts underneath the deck and ends above it, whereas the deck truss means that it starts underneath the deck and ends underneath the deck. So we're going to go with a through truss Howe style. Next, and then you can put your name here. My name is Jiff. The project ID, you can put something there if you want to. 001, 001A01 for like the first one. Once that's done, we can go ahead and hit finish. And here is our, here is our bridge, or at least the start of it. Hello. Okay. Apparently, this does not like to respond to me. Oh, well, this is a fun time. So the screen doesn't update on this window until I force it to refresh, which is going to make it very difficult. So we're going to erase that one and that one and that one. And if we right click over it, we can see that the screen is refreshed and they're erased. So this is going to be a bit of a challenge. I'm sure it would probably be improved if there we go. If I had restarted my computer after installing this, but as it stands right now, this is what we got to work with. So I'm just going to go ahead and right-click periodically in order to ensure that I've got things updated correctly. So you'll notice that this is our Howe truss, which is through the deck, just like I selected, because the triangles are pointing inwards. There's nothing actually here, though. So if I were to run a simulation, it would tell me your structural model is unstable. and give me a few pointers and not run it. So there, well, yeah, I suppose it won't run it. Okay. So what we need to do is we need to basically make this bridge stable, and that could be done just by following the template. So I've got my little circle tool here, which is to create joints. And I'm just going to create joints at all of the circles on this design, and that will form the beginning of our bridge. And if I right click here to refresh everything, yep, I see that. With a few exceptions, come on, computer. Everything's running as it should be. Okay. Okay. So now, as you can see, these dots all along the bottom already have nodes here because this is the beginning of the truss. What I'm going to do is I'm going to select the line with the two dots on either side of it, and this is the member tool. Or, well, yeah, so, yeah, the member tool, which will allow you to draw members that connect to the joints. So let's go ahead and do that. And we're just going to follow all the nice little light gray lines. I'm not trying to move any of this stuff. It's just going to yell at me. It doesn't want to draw. Okay. There we go. And so now we can just draw this nice little design. And just continue all along this, just like we did before. And make sure to draw those diagonals so that you have triangles, because that's what creates stability in bridges, is the triangle design. It's very good at spreading out stress among multiple points so that no point gets too compressed. Now, obviously, this isn't going to be 100% the case. There are going to be some things that we're going to have to fiddle with, and this is probably not going to run on the first try, but let's go ahead and give it a go anyway. And sure enough, oh, there it is. It bent right in the middle there, and the truck doesn't even want to go across. It's too smart for that. So we'll go back to the design. By the way, if you ever want to see the simulation, there's this little sort of horribly blue square button with something that looks like a train or something on it. That's the simulation button, and that will allow you to run a little 3D simulation that tries to emulate physics as best it can. So that's where you saw this whole mess happen, because everything started to be simulated and the whole bridge started to kind of collapse slowly. And like I said, the truck don't want to go across. And if we go back to the design, which has got the little square and ruler and pencils and things like that, we can see that there are some nice little hash marks that now exist on our bridge. And what those hash marks represent are stresses on the bridge. Catastrophic stresses, or close to it, certainly. Red ones are compression, and blue ones are extension, pulling. And we can see that reflected on the bridge as well. Because if you watch this middle part is going to be compressed so hard it's going to bend upwards. And then the bottom parts are going to be stretched out because they're trying to keep being held together. But yeah, so that's not at all ideal. As you can see, there's a lot of angry red. So what we need to do is we need to figure out a way to address these particular points that have angry red on them. And that is how you'll get a functioning bridge. If you've ever played Poly Bridge or oh geez, there are a bunch of other ones right now that are escaping me. But basically physics-based bridge builders and stuff like that. If you've worked with any of those, played with any of those games, a lot of the time, the answer to your problem is to sort of build more bridge. And that's not really the case here. Here, what we're going to do is we're going to mess with the cross section of things, and we're going to change the type of material that they're made out of, and we're going to change the size and stuff like that. So you'll get to see something which seems a little bit less exciting at first, as opposed to something like that where you can just cram more structure in and have it work. But at the end of the day, I think is pretty interesting because it's a look into how bridges are actually designed in real life. Alrighty, so let's get to fixing our bridge. Draw all these. Yep, fail. Back to the drawing board. Now you can see which members failed and why. The ones with the red slashes due to compression. The ones with the blue slashes due to tension. That's the word, tension. I couldn't remember. So we've got a few different things that we're going to take a look at here. Yours does not have red and blue lines, even though you ran the simulation. Oh, you just got them? Okay, that's not necessarily out of the realm of possibility. If mine's been having trouble with updating the screen, I can't imagine that, I'm the only one necessarily, so you might have been running into a similar situation. Alrighty, so now we're at a point where we need to mess with the size of the trusses or the truss bars and the material that they're made out of and stuff like that. How do you see your score? Okay, so you see at the top, there's a drawing of a calculator, and then you got 334, 305, 04, at least in my case. That's how much your bridge costs. Yours is fine, like you had trucks drive across it and everything? Cool, that's awesome. All right, well, see if you can't make it cheaper. It's more than yeah, exactly. Bridges are not cheap. And to be fair, it is more than most people's houses, at least that live around here. But your house is not predominantly made out of steel, and it's not meant to span a river. So I suppose there are pros and cons to each one. Now, granted, your house is way more comfortable to live in than a bridge. So, pros and cons. Cool. 357. Alrighty. See if you can't make it cheaper. But that's a starting point for everybody. Okay, so I can click on individual bars. 20 million. Wow. Okay. I can click on individual bars in order to affect a few different things about them. So we've got carbon steel, which is going to be the cheapest material, but it's also going to be the weakest. Then you've got high strength, low alloy steel, and quenched and tempered steel, which are going to be more expensive and stronger, respectively. So that's going to be the material that it's made out of. Then you've got the cross section. You've got a solid bar and hollow tube. A solid bar is if you were to take one of these bars and cut it in half and look at it like the rings on a tree, it would just be a solid bar of metal, just totally 100% filled in. On the other hand, hollow tube, if you were to cut it away and look at it like the rings of a tree, the middle of it would be empty. So you'd get a much lighter bridge by doing that. You'd get a much cheaper bridge by doing that, but you'd also get a less stable bridge by doing that. Well, I hope you're listening, Cademan, because I'm talking about ways to make your bridge cheaper. Thank you. I am. I am very good at drawing. Man, yeah, especially with a mouse, the best. I'm gonna put that on the market, starting at $20,000. If anybody wants to be a patron of my work, you're more than welcome to. For another 5,000, I will include a head for that face. But yeah, so 100,000, excellent. Your art is in the mail. So yeah, so solid bar is going to be more expensive, but it's going to be stronger. And it's also going to be heavier. And then we can change the size of the cross section. So again, like that cutaway looking at the rings of the tree view, this is going to be, oh God, it's coming back. All right. It's going to be the width and the height. So again, could be empty in the middle, could be solid in the middle, but what this affects is the the cross-sectional size. So what I'm going to do is I'm going to select these two outside bars. So I should have two. I can hold down Control to select multiple ones. And I'm going to increase the cross-section to 150 by 150. And as we can see over here on the right-hand side, here's our test results. These two right here were pretty bad, but maybe not our most egregious offenders. Basically, you want this number to be under 1. So the ones that are red are over 1 on the compression force, and the ones that are blue are over 1 on the tension force. So as you can see, we got very close, very, very close to acceptable values on the tension force. We won't have to do nearly as much. So maybe let's try addressing the compression force first. So I want to make those bars thicker. Perfect. Oh my goodness. There we go. And if we were to check the little diagram here, we would see these bars get a little, maybe perhaps just a wee bit thicker than the rest of them. We're going to do the same thing with these right here. Make these 150 by 150. Move this around. Try and force a screen refresh. Okay, that's not going to force a screen refresh. That'll be good enough. Okay. So now we've got two sets of bars that are a little bit thicker. And as you can see, the graph over. Sure. So you just want to select the bars, and then this third drop-down menu, which by default should be labeled 140 by 140. You just select higher values from there. So I just made them a little bit thicker, so they're 150 by 150 now. $41,000. Oh, you just didn't provide the final equal sign at the end, so it says 41,000. Alrighty, so let's go ahead and run the simulation again, because as you can see, the test results over here on the right-hand side are grayed out, which means that they're no longer valid, and that's because we changed some of these. So I'll go ahead and run it one more time. Let's see what happens. Not much changes, not much is improved, but that's okay. As we can see, the values were lower, they're just not quite 100% there. One of the other things I'm going to do is I'm going to select this middle one, and I'm going to seriously beef it up, so it'll be 170 by 170. And hopefully that should really go a long way towards preventing it. Oh, yep, see, now the middle part didn't bend, but the two sides did pretty spectacularly. In fact, the whole bridge failed pretty spectacularly. So if we select these two side ones, and we set them to be maybe 160 by 160 and run it again. See, we just sort of move the failure outwards more. But that's okay. As we do it, let's just hit all of these and make them 160 by 160. Nice. And as you can see, now the bridge is holding steady, and as the truck goes across, the truck makes it fail. Not great, but our bridge is already looking a whole lot better. We'll make these two bottom ones a little bit thicker, and we'll actually change these edge ones to be quenched in tempered steel, because that's a much, much stronger metal. And we'll check it out. Well, some more failures. But to give you some idea of what's going on here, we can check some of the material over here as well. And if you're ever so inclined, you can click on member details to see more about a particular bar on the bridge. It'll give you a whole bunch of useful information. Let me see if there we go. It'll give you a whole bunch of useful information, like what kind of material it's made out of, how strong the material is, how dense that material is, basically how heavy it is, the cross-section type and size, the area, the moment of inertia, which is basically the amount of force sort of required to change something about it, and then the unit cost. So you can get some idea of how much it costs. And then you get a nice little graph down here to see how it might get wiggy. As it's a shorter piece, as the piece gets shorter, the strength of it increases drastically. However, the tension strength remains the same no matter what the length is. Yes, it is, but that's the whole purpose. I'm not giving you guys the answer. I'm just giving you guys some sort of tools so that you can look into how to sort of look at it from a got it down to 10 million. Nice. Look at it from a critical eye and see how you can make it cheaper. Hey, a 50% reduction in cost is amazing. All right, that's going to go ahead and do it for today. We'll leave it open for question and answer time, and also because I got to give my head a rest. But if you have any questions about anything, I'm here. Otherwise, you're more than welcome to head out. I'm going to go ahead and skip the poll questions in the interest of saving time. But like I said, I'm here if you have any questions. Otherwise, you're more than welcome to head out and have a wonderful weekend.